According to the International Maritime Organization statistical studies, the greenhouse gas emissions from shipping, including carbon dioxide, methane, and nitrous oxide, have increased from 977 million tons in 2012 to 1,076 million tons in 2018, with 9.6% increase. We are Rauma Decarbonizers, and our task with Rauma Marine Construction is to review the current regulations and find solutions to decarbonize the emission from short sea shipping. My name is Ahmed Yusri, and with my smart team, Ankita, Xiaohan, Maria, and Omo, we are going to present our solution.
The first task that we faced was to deal with the regulation regarding the Rauma company, and we focus on the international within IMO and regional within EU levels. When we talk about IMO, it is about the energy efficiency existing ship index and the carbon intensity indicator. Put simply, the EEXI is a framework for determining the efficiency of the design of vessels, while the CI is an operational measure of how efficiently a ship transports goods or passengers. If we talk about the EU, its regulation isn't about frameworks but has a direct economic impact on all shipping industry, and it is about the taxation system and emissions trading system, where allowances for gas emissions must be purchased, and we must deal with it in nearest future because ETS like the CI have gradually increasing targets to reduce emissions, such as 11% of reduction in 2026 from the 2019 level.
After reviewing the rules carefully, we find that the best and most futuristic solution is to consider alternative fuel rather than the heavy diesel that emits a dangerous and intensive amount of greenhouse gases. In addition, improvement of the ship operation logistics should be considered within the decarbonization initiatives. So, we are glad to introduce our zero-emission vessel Saima Hybrid. Hybrid refers to the ability to transfer passengers and cargo at the same time. The vessel operates using electric motors that are powered by hydrogen fuel cells. But it is not only a zero-emission vessel. It is designed to operate in a specific navigational route that suffers from deficiencies in operational logistics. Our logistic solution here is the operation in the 4 seasons. The current cruise ships in this route operate only in spring and summer. On the other hand, the cargo demands are very high in the icy winter. Compared with Saima Hybrid, she can operate all seasons, so we also got high profit and encouraging solution at the end. The hydrogen solution is applicable today for most short sea shipping. However, the logistic one can be applied after studying the trade in each route individually. Then, the question is, what is the route that we are talking about? The route we considered connects Saima Lake in Finland to St. Petersburg in Russia through Saima Canal. But why this route specifically? That's because there is a potential extension of the canal with the increasing temperature rates between Finland and Russia, and hence more potential ship traffic is expected. In addition, Saima is the habitat of endangered Saima salmon and the freshwater seal, the Saima ringed seal, which are living only at Saima. Moreover, Saima is the 4th largest natural freshwater lake in Europe. So, the greenhouse gases in general and in this area particularly may contribute greatly to the destruction of this stable marine ecosystem, and hence we must act promptly. We have studied the required energy to power our vessel Saima Hybrid. Based on the electric load balance study we have conducted for several loading conditions, we need maximum of 1083 kilowatt. Therefore, we have selected 5 fuel cells to power 2 electric motors with total power of 1500 kilowatt. Based on our design, we need volume for this system similar to the normal diesel operating ships. In addition, the new system offers low vibration and hence more space can be utilized for passenger facilities, comparing with the normal ships. Here we can see a proposed general arrangement of our Saima Hybrid. Hopefully, this new general arrangement may achieve the best utilization of the available spaces.
The concept we have offers a possibility for maximum carriage per voyage made across all market seasons. During summer, when there is a significant amount of holiday travelers, it is possible to carry up 220 passengers with a considerable amount of space for cargo. With this optimized carriage potential, we can carry more and consume less of the energy, thereby having low emission and meeting maximum efficiency.
But is this grand plan economically viable? we see that on the cost side, the upfront building cost is going to be $16.57 million based on battery and fuel cell systems costs. On the revenue side, though, we see an annual net cash flow of $2.73 million based on passenger and freight charges. Putting together the upfront cost and the revenue from multiple years, we see that the cost will be covered by the revenues in just 8.6 years, and considering that the ship is going to last for at least 25 years, this is going to be a hugely profitable venture with a return on investment of 11.7%. Totally worth investing in.
The advantages of our design are zero emission that can meet relevant restrictions and also have high profits. Obviously, the weakness is the low cargo capacity, but the hydrogen facility have the possibility can be improved in the future, and it has less competition on hybrid cruise and cargo business. We have to say there are several threats like new technologies and uncertain passenger demands, and the optional cut in case of long and severe winter due to S-class and low available power.
Finally, we would like to thank you for your kind attention.